So I'd like to introduce Christian Prilhofer. He is the owner and CEO of Prilhofer Consulting, and he began his professional career as a mechanical engineer. In 1994, he founded his company in Germany. And since then, Prilhofer Consulting has established itself as the world market leader in planning and consulting for industrial production. Numerous factories have been planned worldwide, and the precast concrete building system has been successfully introduced. So please welcome Christian.
Thank you very much. I'm happy that so many people are coming at this last presentation of the day, or maybe the topic of using data in the construction industry is not that interesting. As said before, we are the world market leader, and our product is just information, planning, and advice. So we are not delivering any machine, software, or other things. And we do this for all the customers worldwide because precast or prefabrication, and you have a factory, you need more than just one machine or one system. So this is an integrated process, and for that process, so you need different players like software, hardware, machines, cranes, whatever. And we bring them all together. And this is what we're doing. And our product and all that is like the architect in a building. The architect also didn't make windows or whatever. He's just responsible for design and that everything works together. So it means our product is purely the success of our clients. The productivity in construction, all these big consultants like McKinsey, they wrote a lot about that and think a lot about that. And in 1998, there was this investigation, and the end of this investigation was the problem is information. The problem is not material, not workers, not whatever. The problem is lack of information in the construction. And then BIM was invented, or how to say, but this was just a result of things that was happening before, because also before you cannot build a building without having any drawings. But BIM is, I don't know, the new tool that combines everything together, all the information. What we see is, or where are the data coming from? And this is the biggest problem for efficiency and for all these things, and also what we saw before. We should not collect data. We should produce data. And this is the only way to get efficiency and to get more automation, to get all this. And the big problem in the building industry compared to, let's say, mechanical engineering, car manufacturing is we didn't build a building twice, or most of the time. Means for every building, we have to create a new set of data. When I produce a car, I have the model of the car, then I'll make it, I don't know, a million times with the same database. And I didn't have to change anything because it's mass production. And when we think about mass production in buildings, we have to have always real data. New building, new form, new appearance, new set of data. But without that, we will not have the chance to be more efficient. Means having the BIM model for a building is good. We can use it, we can have a digital twin, but for the next building, we have to do the same. And then this is the only chance to move forward with the system. Don't having that means having problems. And the art of that, having the information, is using the information as information, not falling back to drawings or PDFs or tablets or whatever. In the past, when I have a draft board, I make my drawing, I copy it, and I give it to the worker. So this was a process, cannot be changed. But today, using a computer, making CAD drawing model, and then give it to the printer, or making a PDF, this is not the way to go. But currently, this is the status. When we think about data usage, what should I say? You go to the building site, you get information, drawings in PDFs and whatever, and then you start again. Means the information is lost. You have to orientate yourself, you have to measure, you have to do, or you use scanning devices, pixel clouds or whatever. The smart process is, I'll take the data, I have the information, the BIM model. The BIM model is vector oriented. Means I have to take the information and then convert it into machine language, into HTML language, and then I can use the data direct. And so I'm not losing information, I'm not losing accuracy, I can use it direct. From the CAD system to the machines to the part. And this is the way to go. And with this, we gain efficiency by itself, because I can skip so many processes, they can cause to failures or to delays. How did this start in Europe? In 1985, all of a sudden, we have personal computers, we have CAD systems, and we have PLCs. And everybody can have it and can use it. And at that moment, the precast producer saying, why can't we use the data direct? And what you see in the pictures, this is Longback Productions. And in the past, the guy with the drawing was over, start to measure, start to do, and it takes him an hour for one bed. Then plotter was introduced. They said large scale plotter goes over 10 minutes, all the information on the bed. And same with reinforcement, because with reinforcement, they go away from the meshes to single pass because of efficiency and don't have this much waste. Then somebody has to be there at the machine putting in 20 pieces, diameter 10, length 6 meters. No, the information was direct at this time with floppy disk from the computer to the machine control. And this was raising the efficiency for 50%. But the workers are not working fast or whatever. Only the processes that are not necessary were skipped by using the data direct from the computer into the machine. And you know, this was the time where a fax machine was state of the art to transmit data. And at this time, nobody knows that it was BIM, but it was there. And why was it done? Because of competition. The competition between the precasters in Europe, especially Middle Europe, Germany, Austria, is very hard. So you have to differentiate yourself from your colleagues. How can you do that? Everybody has to use the same amount of material, steel, cement, whatever. The only chance is to reduce labor cost. And the idea was not to be modern, not to be whatever, just to reduce labor cost. And so all these things started. Where are we today? This is a picture of a modern production unit, and you see this doesn't look like concrete production or whatever, but this is a modern production of walls. We have a BIM model, but what kind of model is it? It is something for advertisement or for as a sales tool or whatever, but this is not the model everybody thinks. When I have a BIM model, I have the information. In reality, I have maybe skin and bones, but I don't have a heart, I don't have nerves, I have nothing. And who knows that? It is known by companies, they start to produce, because when they import the BIM model, they see it's empty. It's a shell. Because what are they expecting? They're expecting to have all the information about electricity, about reinforcement, about everything. But today it's not there. So what do they have to do? They take the model and make a better model out of the model. Because when you produce it in an automated way, you need all the information about reinforcement, about connectors, about everything. And when having this, it's not necessary to send a robotic dog through the building, checking is everything there. Because when it's there, the machine put it in, it is there. And then I can skip all these processes, and then I know I have the digital twin. Why? It's done in the way that the machine do it. And the machine, they have zero failure tolerance. Means either the information is correct, then the machine does it, or the information is incorrect, then the machine said, sorry, it's wrong for so and so, so I cannot do it. Where do we have to go? To be more efficient, we need all this data. Currently, we need, let's say, just as much data as everybody thinks to have on the building site. And then the next question is, we need skilled labor. When I have clever machines, I don't need skilled labor. This is the same like in the automotive industry. They don't have skilled labor at the assembly lines. They have people, they go there and they are trained to install a wheel or to install whatever, a door. And this must be the future, because having too skilled people means getting too costly processes, and in reality, the brain work should be done in the office, not on the building site. Sending incorrect information, and then we need skilled people and say, yeah, this is not right on the drawing, but it doesn't matter, I know how to do this, so I will fix it. And when we talk about the digital twin, about what level of accuracy are we talking about? When I have precast or prefabrication, I have everything. Because what is not in the model is not in the part. It's not there. So I'll get it. I get this information for free. Because I have to have it, otherwise I cannot produce. And we know when data is available, then everybody wants to have it. You need data for this and for that. And when using prefabrication, we raise efficiency and we get all this for free. When I take the current building process and then I have to put BIM on top, I make the process more expensive. Why? Because I do something and at the end, most information cannot be used on the building site because the tools and everything is not there. Also, today, I heard a lot of presentation about AI. How can I have artificial intelligence when I don't have data? And all this goes hand in hand. So at the end, if we don't go to efficient processes, just producing data, then BIM is a disadvantage. Why? I do a lot of things and at the end, nobody cares, or I do it only for the digital twin, but not to make the process more efficient. And the efficiency in the process comes only with automation. But automation on the building side failed. Since the 90s, there are a lot of tests, putting robots, putting bricks, 3D printing, whatever is tested on the building side. But everybody knows the environment on the building side. And then you find out it's hot, it's cold, it's windy, it's whatever. And machines with a certain precision cannot work there. And then I have to build a temporary building over the machine, over the building. And this is not the way to go. Maybe for a single family house, but this is not the way to go for mass production or for multi-story buildings. This is a picture of a modern production plant, how it should be. There is the Dutch plant on the one side, production of walls, production of floors, columns and beams, automated production of reinforcement in the middle, with automated delivery of reinforcement in the form. Means the reinforcement is done 100% automatic. Data go in, the machine makes bars, cuts the bars, welds the bars in the shape of the wall, of the floor, and then a robotic crane picks it up, puts it in the form. When we look at the traditional process, only in the middle area, we would have 30 people just doing stupid work, measuring, searching, doing whatever. Why? Because we don't have correct data. With this system, this forces you to correct data, because otherwise you cannot drive it. You can only produce when you have correct data in a certain format. This was a plant in Hungary, opened last year. So automation is not the end itself. So automation is the answer for the upcoming changes. As I said, lack of workforce. I don't need skilled workforce in the factory. I need people that are willing to work, that are motivated. And when I remember in the 90s, a worker, all information he got from the television, from the radio, and from the newspaper. And then you have to force this pure guy to work with an automated machine. It's a small display, and then he said, failure F10, you have to do this and that. This was a real challenge for all the people in the 90s to work with automated machines. Today, when somebody uses a smartphone, he can easily work in the factory because all the information he gets is window-based and he knows how to do this. And so it's not important anymore that we have skilled bricklayers or whatever. We need people that are motivated to keep the factory running. And we train them for one job, reinforcement, molds, whatever. Same in timber industry. I train them for one job. This can be done in a few weeks, and then I can produce in a better quality as on the building side and simpler. We are reducing CO2. Why? We are slimmer, we use the material better, and we are not producing any waste and dirt and noise and all these things. We had a project in Singapore, and the biggest problem there was noise on the building site. Why? It is so congested, and they are basically working 24/7, and so the Singaporean government banned traditional processes on the building site. Why? Because all the neighbors were complaining, and this is a problem. And we get also much higher quality of buildings. Why? We are producing in a millimeter range, means everything fits there according to the drawing. And we not rely to any workers or to other things. It's produced piece by piece, like when I make a machine. I have workshop drawings, and everybody makes a little piece of the machine. And at the end, the machine fits together like an engine, and it works. And I'm not relying to certain trades or other things that they do this right, or they do this in a way as it should be done. And also health and safety, which is also a big deal, that on the building sites, it is more and more problematic with people that are maybe not so good skilled to work. And when they just have assembly work and they bring away all these other processes which are dangerous or needs more preparation, then I'm faster. When I make today, I can make bathroom pots, and all the trades for bathroom tiles and everything is done in the factory. So I ship the bathroom to the site, I install it, and 20 minutes later, in theory, I would be able to use it. The biggest problem with prefabrication, especially for contractors. Why? This requires a new way of thinking, a new company structure. And in one presentation in the morning, somebody said, contractors are trying to reduce the workers in the office. This is if I would think about smart animals, I reduce the brain to be smarter. So this is something which is not working. It's the other way around. I have to think, how much of my workforce can I reduce on the building side? And then if I can reduce 20 there, maybe I get 2 more in the office. But this is a benefit, because I will get these 2 more in the office in any case, because in the future, authorities and everybody will request more information. So I have to upgrade the office, and if I don't use the information that are creating there on the side, I have a disadvantage. And we see this from all our clients all over the world when we get an approach and say, I need a movable factory, then we know it's a contractor. Because the contractor is like a gypsy moving from side to side, and then say, how far do you want to move it? Yeah, 30 kilometers. And why? Yeah, because we do it always, we move from side to side. And this is, and when you see with this thinking, you're not able to be more efficient, because we need to change the process. And the process is as it is here. It starts with architecture, building system, structural, and it goes just in one direction and not back, and not say, yeah, in theory, we know how the building should look like. Start digging, start doing something, the information will come. This is the wrong way. because this leads to inefficiencies, and this leads to problems. And there are a lot of companies in the exhibition that make small patches for these problems. But the real problem is bigger. We have to start with a new approach. And the new approach, this is, how to say, the biggest pain for everybody who's in the construction now, that they have to change their processes totally. Do everything before they start on the building site, do all the planning, do everything. And then after that, when this is done, think about production. Not think about doing things on the building site before having any approvals, having an idea about electricity, having an idea about windows. This leads to that problem. And the good companies, successful companies in the world, they are following this principle. But the interesting thing is, all these companies, they were not starting as contractors. They were starting as real estate developers or making agricultural products or other things. And for them, it seems to be easier to go into this process and said, yeah, why should we do this as we had done it before? Why shouldn't we start new? And then you don't have the middle management, which doesn't want change, which has a lot of excuses why it has to be done in the way it was done before since, 50 years. And with this, bringing a little scanners or bringing other things, this is not the solution. This is just small things to release the pain. Because what we always say, prefabrication is a different way of construction. This is not another building material that we say, we have now another building material, we have prefabrication, we have precast, we have timber. No, this is the result. The result of the brainwork in the office is that we say, okay, it's maybe smarter to produce it, to streamline it, not to say we start everything at once and then after, a few weeks, we look where we are and then we correct ourselves. This is not the way forward in efficiency. Same process in a different form. In the middle is the data. And so the circle is the same. But everything has to go via data. And then it works. When the confirmation comes, engineering, production, installation, and nothing in between. And not to say, let's ship it, and then afterwards we think where we can make the openings for the pipes. No, we need to know where the pipes are. Then we put the pipes in the CAD system, in the BIM model, and then to make an opening in fresh concrete, it's easy. Or to drill a hole in the factory, it's 20 times easier as to do this on the building site. Why? I have an environment, I have everything. And I know where this should be done. And this is the heart. And the rest is following what the brain. It's the brain, and the rest is following the brain. When you see villas in Thailand prefabricated, apartment building in Austria prefabricated, and both of these buildings can be produced in the same factory simultaneously. And how is it possible? Because the worker doesn't know what kind of building. The worker just has to keep the factory running. And the information comes from the CAD system. And the one wall goes in the apartment and the other wall in the villa. For the worker, it's the same. It's reinforcement, it's steel molds, it's concrete, that's it. And to switch over, I don't have to tell the workers or foreman, we're producing something else. No, it's not important. Because data are there, data are sent, and it's produced. And the advantage is the efficiency by making a wall. If I do 100 times the same wall or just once, it doesn't matter. The efficiency is the same. And this makes it interesting for automation. Because in the past, all the prefabrication has a bad name. Why I've said, it's so uniform, it's this and that. It's not necessary to build buildings that are uniform. Why? Because when we have data for a machine, for a robot, it doesn't matter where to place the steel mold. Same place as before or somewhere else. And this gives us possibilities in appearance and flexibility. But as said before, without data, no automation, no efficiency. And we also are very proud to have one of the leading companies here in Canada, Stubbies. And what is interesting, they are coming from agricultural precast. And so it maybe was easier for them to analyze the process and go a different way. And this is from their website. So when you go to Stubbies' website, you get this. And when you see here, this is the interesting part. How can this be done? Because everybody said the building process is complicated and complex. As we see it also as outsider, because we are not building, we're just consultants. We see the problem is more the parties involved. They are complicated, not the process itself, because we build houses since, I don't know, more than 1,000 years, and we can do this. But from year to year, the players in the system tends to get more complicated. They don't want to pass data, they don't want to do things. One of the biggest problems with BIM is also, is one company giving their BIM model to the next company? Let's say the architect to the structural engineer, the structural engineer to the HVAC. No. Why? This is my model, this is my data. This is not the way to go. So this is the right approach. They care about the model, they care about everything. Makes it easy. As you have to fight with a lot of people about data, about responsibilities, or about other things. And for contractors, they have to follow. But it's not that easy to say, okay, from next year on, we are, I don't know, more efficient. This is a change in the structure. This is another building with the same effect. To see, this is in the model, and this is there before the building is built, and the information is in. And when I need a bill of quantity, it's easy. I just press a button and it's there. I have everything. And this is what we have to do. And this starts in the technical office. This starts by creating data, not collecting data. When I build a building like this, I don't have to send a robotic dog through the house and say, is everything there where it is? No, it is there because it is built in a factory and the worker just sees one piece of all. And he has no flexibility to say, no, I put this connection somewhere else. Because if he puts the connection not where it's designed, it's a problem on the building side. So I can skip also a lot of these new processes, unnecessary processes, because it is there. And when I build a car, then the part is made. And there's maybe a quality control before I send it, but at the assembly, nobody starts to measure the parts again and said, I have to measure this crankshaft because maybe it doesn't fit in. No, this is the wrong way. The right way is do it right, give the information there where it's needed, and then I can use it, and then efficiency comes by itself. And by creating more, processes, also data collections, other things, we get no efficiency. The only thing what we do is we raise the price of the building, of the process, just collecting data. And then everybody's complaining and says, yeah, building process, very complicated, very costly. The idea is change the way how to build. Then I get a lot of things for free. I don't have to do this and that and go to the building site, do other things, have supervisors, make archives, send data back and forth. It's not necessary because it is there. And I don't have to send somebody and say, check the wall on the building site. The wall is done automatically. And better check it inside, easy, efficient, and not to bring it there. Somebody has to go there, check it, recheck it, all these things. This is just waste of money, waste of time. And the idea is look at other industries, manufacturing, electric industry. They do this since 60, 70 years. Henry Ford started with the first idea of that. This is what you have to have. Henry Ford doesn't have computers doesn't have modern things. Today we have it. And with modern production methods, we can build all the buildings, and it doesn't matter if the building is always the same, like the Model T. I can produce endless buildings with same efficiency. Why? I have the tools. Factories are there. I only have to change my processes. I have to produce data, and then I can do this. I can produce in an efficient way without having all these things around. This was it. I hope it helped you. This is, for us, this is the only way forward. We see this around the world because Canada is not a special country which is a lot of different to other countries. Canada is in the range of developing countries like Europe, like US, and they all have the same problems. And the way to do this is to make a drastic change, not small steps. With small steps, we try small steps now since 50 years, and you see productivity doesn't raise a lot. And new buildings, these are more machines where we live in, not the building as it was before, a few walls, floors, and windows. Thank you very much. Are there questions? Or please.
I'm wondering if you can speak a bit more about the role of regulations and legislation on improving some of these processes. So for example, in your studies slide, I think the graphic was the studies fast track product could replace or streamline the architect, the mechanical engineer, or civil engineer, or structural engineer. Does that mean that studies in providing this product for regulatory purposes also provides like stamped drawings? Or how does that piece, how does the regulatory piece of having an engineer sign off on design get solved in these processes?
I think what this graph should say is they don't skip it. They have to follow the process. But when you do this in-house, then you avoid fighting, you avoid overlapping, and they work in one model. And today in reality, when you do this, the null process, you work with 3 models, and then importing, back and forth. The idea is not to do something what is not according to standards or whatever. The idea is to do just what is needed, not more. And today, when you see what is created in data, maybe there is 50-70% waste because the one party doesn't give all the data to the next party and again and again. And this makes the process slow and costly. What Stabi is doing is according to all standards to everything, but they reduce it to that what is necessary, not to do something which get paid and at the end is unnecessary, because all the unnecessary processes must be paid too. And this is one of the reasons for poor productivity and for high cost.
Thank you.
You're welcome.
So what are some examples of ways that you can streamline that information transfer? So like in design, you have like the architect model, the structural model, mechanical, you link them all together so you can see what everyone's doing. But then when you go into construction, they basically throw that in the garbage and remodel everything. So that's a huge inefficiency, right?
Yes, why? Because when you pass a 3D model to the next party, you're naked. They know what you do, how accurate you make the drawings, how accurate you do everything. And for the building side, I don't know, 3-4 millimeters, doesn't matter. Nobody cares. But when you want to do this in an automated process, so you import it and say, okay, I have to do this. See, okay, the support is not correct. This is not correct. Building side, they say, yeah, it's not correct, but I know, I'm skilled. I know how to do this. But the machine has 0 failure tolerance. So you see the model, and you see the model, I wouldn't say it's wrong. It's not made in the precision as it should be. And this is the reason then for all the precasters, they say, I can use maybe the overall dimensions, but the rest, the supports, the openings, all this is not done correct. So I have to redraw the model, because if I don't redraw it, I cannot use the data for the production. Because what do we have to do? This vector-oriented drawing has to be transferred in machine language, like when you have a printer driver. For a printer, it doesn't matter which hardware and which software, you have to transform it in printer language, and then the printer prints it. And this is very similar to the machines. You have to transform the information from vector to machine language, and then the machine is producing it. But we need real accurate data. And if there's a bar, it has to be diameter 10, not 9.9 and not 10.1, because the machine said, sorry, I don't have this diameter. I cannot produce it.
Yeah. So would it make sense, of course you need a different contract method, but to bring in like the precast manufacturers during design and they can work on the models?
In Netherlands, they have something they call building team. And building team means the precaster is sitting at the table from day one. This makes the process more efficient, because then when the precaster has also an opinion that, look, we cannot do this, we cannot make huge cantilevers. If you do this, you double, triple the price, or things like that. What we see around the world is the future is there will be bigger companies. Like one of our best clients in Thailand, they come from real estate development, and they say, okay, we have to be more efficient, we have to build more. And at the peak, they were building 50 units a day, 50 units a day in 3 factories. And how can you do this? When you think about a traditional process, think about the workers, the supervisors, it's for clear. With precast, it's easy. A small building site, 1 crane, 4 trucks, 2 days, done. Next building site.
And sorry, I'm with Stubbies. For many of our total precast buildings, the ones we're probably most successful at is we'll work directly with the owner, and we're part of the design right from day one.
Yeah.
Or else what happens is the architect will design it, and when we're brought on board, you're kind of back to the drawing board, you know, rejigging everything, making it precast friendly, whereas we're involved right from day one. It's a lot more efficient.
So does that come from the architect suggesting they want to do precast panels, and then the
Usually the owner.
The owner.
The owner of the building.
Okay.
The architect is an artist. The architect wants to have.
Yeah, it's to convince the owner, because the owner is gonna endorse that decision, correct?
No, every case is different, but it often comes from the owner.
No, I mean, yes, if you go to the owner directly, because he's the one making the decision, especially if you are in later stages, right?
Mhm.
And also, it's more complicated if you add, the first question we had about the regulations, if you switch from some, depending
Yeah,
on
correct.
the point that you are in the process and the design phases, you need to switch gears, and then later it's more complicated.
Yeah, no, I agree.
I think what we are talking about Toyotas, not Ferraris. Mass production is we're building Toyotas, and this is maybe in quality-wise better than a Ferrari. Maybe not just prestigious, but better car. And we have to think from mass production. We have to think about prefabrication. If somebody has a lot of money, they can build a house, however, doesn't matter. But for the crisis in apartments, in living space, we need to build Toyotas. Very good, affordable price, fast. This is what we have to do. And then the owner said, sure, I want a Toyota because maybe I'm not living in. I want to have it fast, good quality, and less complaints from attendants. So what do I build? We also had one interesting approach from Germany, from a real estate developer. And this guy said, I want to have a precast factory. And I said, why? Yeah, all the problems on the building site and with the future owners, they come and measure and we fight for things and that. And the architect said, I cannot make decision before I'm in the building, things like that. And when you analyze this, you say, okay, I want to get rid of all these guys. I want to have prefabrication, installation, and then it's there. And the architect has to do his work before we start on the building site. Why should an architect go to the building site? If he done his work correct, what should he do? It is there. Do you see designers on the assembly line of car manufacturing? They're not saying, oh, look here, this hole. No, they do the work, they send the data, that's it. This is the new way. But yeah, tradition sometimes, and maybe also wrong payment systems, or how say fee systems, that it's necessary that architect goes to the building site. For what? If he gives all the information before and they follow the information, it's like as he designed it. Not to say you have to come and you have to see this and you have to correct this and this. No, this makes the process complicated, slow and expensive. I come from mechanical engineering, and for me it was new when I come in the building industry, and when I heard, because in mechanical engineering nobody would start to build a machine without having all the drawings. So now start, let's cast the body, we think about the rest. So in 2 weeks we send you the rest. I said, no, if we don't have everything, we don't start.
Yeah.
In building it's normal. We start, we can imagine how it looks. Let's dig.
Yeah, that's happening a lot more.
Yeah.
It's like, oh, we
Yeah.
designed the company.
Yeah, and
let's
then
pour it.
you think you are more efficient by reducing the overhead.
Yeah.
How? You reduce the overhead and then you say, I save, doesn't matter what it costs. Because at the end, it costs more. All the correction on the building side costs more as you do this in the design of it.
More questions?
Thank you again.